Hey guys, today we're going to talk about k-means clustering algorithm. In this video we are going to cover the basics of k-means clustering followed by a step-by-step tutorial of how k-means clustering works with an example. But before we dive into k-means clustering, let's firstly understand what is the difference between supervised and unsupervised learning. Supervised learning has labels associated with it. Just like these are the cross-labeled data points and these are the circle-labeled data points. However, in unsupervised learning, the data points are unlabeled, so we cannot tell if a data point is circle-labeled or cross-labeled. Therefore, unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled datasets. As you can see here, we have clustered the data into two separate clusters. So k-means clustering method is an unsupervised learning technique used to identify clusters in a dataset. The k in k-means represents the number of clusters or groups we want to separate our data into. The algorithm will categorize the items into k number of groups based on similarity, and to calculate the similarity we use the Euclidean distance as a measurement. Customer segmentation is one of the popular applications. Let's quickly understand how k-means clustering algorithm works. Let's consider this example. We take the weight and height measurements of 11 students in a class. On the x-axis we have weight and on the y-axis we have height. We'll plot them onto a graph. Select a value of k that tells us how many number of clusters we want to identify. Here let's assume we want to identify two clusters, that is k is equal to 2. Step 2. Initially select two random data points to be our cluster centroid. First example to represent blue cluster centroid, that is K1, and the second example to represent a red cluster centroid, that is K2. Step 3. Calculate the Euclidean distance between the centroids and the data points, where nearby points would be said to be similar, and this is the formula for calculating the Euclidean distance between two points. We take the difference between the x coordinates, add it with the difference between y coordinates, and square it just because we want the result to be a positive number. For instance, let's take this point. Measure its distance from K2 cluster, comes out to be 4.4. Then measure its distance from K1 cluster, comes out to be 19.8. As the point's distance from K2 cluster, that is the red cluster, is lesser than the K1 cluster, that is the blue cluster, we can say the point belongs to K2 cluster, that is the red cluster. Step 4. Assign the point to its nearest cluster. Here it belongs to the red cluster. Step 5. Readjust the centroid by taking the average of new cluster. Here when we take the average of red centroid, and the average comes out to be 58,167 to become our new centroid. Step 6. Repeat the process until each point belongs to a cluster, measuring distances of each point from the centroid, assigning cluster to the point, averaging the cluster whenever a new point enters the cluster, and then relocating it so that it finds its center of gravity. Then we again take this point and again calculate the Euclidean distances and assign it to the nearest cluster, then average the cluster and relocate the centroid. And we do the same for our blue cluster. Now let's discuss the potential problem of using k-means clustering. K-means clustering algorithm is sensitive to randomly chosen initial conditions. Therefore, choosing the right initial centroids becomes important. Suppose our initial centroids looked something like this. Not only it would take longer to converge, but we will get a different result for our cluster. So we need to make sure that our initial centroids are distributed all over the data. Thus, while implementing the k-means algorithm, we use initialization as k-means ++ instead of randomly selecting initial centroids. K-means ++ selects initial centroids using sampling based on probability distribution of points. Remember I said to you to assume the value of k? Here let's assume we want to identify two clusters. That is, k is equal to 2. There is a way to find out what the best value for k would be. And we don't have to assume anymore. So how do we find the optimal k value? Firstly, let's ask ourselves a simple question. How are we so confident that there are only two possible clusters? There can be three clusters like this, or even four clusters like this. Well, the confidence comes from the elbow method. Here on the x-axis we have different values for k, and on the y-axis we have the sum of squared error. Let's understand the role of sum of squared error in k-means clustering. When k is equal to 1, we get one big cluster like this. Here we can see when we have one centroid, the variance is very high. We compute the error by summing up the difference from each point and the centroid using the sum of squared error formula. So when k is equal to 2, we get two distinct clusters like this. We compute the sum of squared error for cluster 1 using this formula. Then we compute the sum of squared error for cluster 2 using this formula. Likewise, we derive all the sum of squared error when k is equal to 1, and then when k is equal to 2, when k is equal to 3, and so on. You can see the variance when k is equal to 2 is comparatively lower than the variance when k is equal to 1, as all the points are in close proximity to the cluster centroid. We go back and plot all the k values as well as the sum of squared error onto the graph. However, in k-means clustering we call it WCSS, which stands for within cluster sum of squares. Here in the elbow method, we will pick the point that looks like an elbow joint, and that would be the value of k. Here in this case, the optimal k value is equal to 2.